So again, what we are looking at today are the relationships among the sides of 30, 60, 90 triangles. They're named that because those are the angle measures of all of these triangles. We have a right angle, we have one angle that's 60 degrees and another angle that is 30 degrees, okay? What you are going to do, again, this is going to look pretty similar to what we did last time. You are going to find the length of the missing side of each of the following triangles, show all of your work, and put your answers as simplified radicals. Now, I do need to go over a couple of things with you before you get this started. So if you look at this first triangle, it's a little blurry, but I think we can see it well enough. The right angle, of course, is marked. The 30-degree angle is kind of the one up at the top, and then that would leave the 60-degree angle down here. And those angles are going to be there for the next two triangles as well, okay? Okay, one thing that I want you to think about is the hypotenuse of a right triangle. In general, the hypotenuse of a right triangle is what? What do you know about it?
9 times the square root of 2.
Okay, well, that's for 45, 45, 90. I'm talking about all right angles in general. Jessica? Okay, the hypotenuse is always going to be, good morning. Hypotenuse is always going to be bigger than the legs, the longest side. Okay, keep that in mind. Now let's think about the other two legs of this triangle in particular. They're not going to be the same length like they were on Monday with the 45, 45, 90. Which one do you think is going to be longer than the other, though, and why? Talk with your table for like 30 seconds. Talk with your table for 30 seconds. Which of those two legs is going to be longer and why? And your why should not be because the picture looks like it. So if you need to take more time. Huh? Lauren, what did your group think?
I didn't think anything.
You didn't think anything.
No. Okay, well, I don't know if this is better or not, but like we said, since 60 was in that bottom right-hand corner and then there's the top, like the longer length is going to be like the one that's, yeah.
You're getting there. It does have to do with the angle measures. Emily, what did your group say? Say what, Mark? Okay, so the legs do have to do with the angles. Joel, what did your group say? I'm sorry, what?
The angles have something to do with it.
Taylor?
Is it because 30 and 90 add up to a bigger number than the 60? So,
No.
nothing.
Carrie?
Is it because the further away you get, the more the smaller the angle gets, the more it has to stretch? Here.
Can you elaborate on that?
Okay, so you have the triangle like this, and if the 60-degree vertex was like here, then it'd be a lot smaller than 60 degrees, but since it's like right here, yeah, I don't think you get it.
I don't think I do, but that's okay.
I understand what he means, though.
I
Okay, so Rachel, rephrase what he said.
He was pretty much just saying, like, since, like, if the 60 was further away, then the angle would have to be smaller.
Okay.
Because, like, the further away the angle is, the smaller it has to be.
Okay.
In order to, like, stretch to reach the other ones.
Okay. Let's think about this. you guys told me that you know the hypotenuse is the longest side, right? And the 90-degree angle is what
Alright.
compared to the other two? It's what? It's bigger. It's not a coincidence that the hypotenuse is the longest side when it's opposite the biggest angle. Okay? So if you kind of use that thought, the side opposite the kind of middle angle is going to be the next biggest, and then the side opposite the smallest angle will be the smallest side. I think you guys were kind of getting there, okay? So keep that in mind as we go through this. Now, the other thing, I do need to give you a little bit more information on these triangles because you're not going to be able to calculate the length of the third side only given one. So what I'm going to give you is the lengths of a couple other sides. So jot this down on your paper for me. In the first triangle, the length of the hypotenuse is 2. In the second triangle, the length of the longer leg is 2 radical 3. And then in the third triangle, the length of the hypotenuse is 6. Okay? You need those additional sides to be able to find the third. So again, similar to what we did last time, in each of these 3 triangles, we'll use the sides we're given to find the length of the third. Nolan, how can we do that?
Separate equation.
Not a proportion.
A equation.
What kind of an equation?
Like for which one are you talking about?
Like for this first triangle, how would we find the length of that longer side?
2 equals 1 plus x.
Not quite. How do we find sides, missing sides of right triangles?
I forgot.
What did we use last class? Scroll up in your notes if you need to.
Is it the A squared plus B squared?
What is that called?
Pythagorean.
Okay. So let's use Pythagorean theorem, similar to what we did last time. I'm sorry, what?
No, just keep going.
Okay. To find the length of that longer leg. So we're finding the length of a leg, so let's say that that's A. So we'll find A squared. We know that the length of the other leg is 1, so plus 1 squared. The length of the hypotenuse is 2, so that equals 2 squared. Let's simplify. So A squared plus 1 equals 4. Subtract your 1. And then take the square root. Remember, we want our answers as simplified radicals, which this is. So the length of that longer leg is radical 3. Okay? You are going to do, again, like we did on Monday, similar thing for the next 2 triangles. Taylor?
Is 1 radical 3 the same as radical 3?
Yes, 1 radical 3 is the same as radical 3. Yes.
Okay.
Okay. All right, let's come back together here. Justin. Well, first of all, we already had done the first triangle together where the short leg was 1. We knew that our hypotenuse was 2. The length of our long leg was radical 3. Justin, what did you have for short leg lengths of 2, 3, and 4?
Mean the long leg?
For both the hypotenuse and the long leg.
Both.
Yep.
I got 6 and 3 radical 3.
Okay, what about 2?
4 and 2 radical 3.
Okay, and for 4.
8 and then 4 radical 3.
Okay. Jenny, what did you guys get over there for short leg of 5, 6, and 7?
12 and 14.
Okay. And then for the long leg?
5 radical 3, 6 radical 3, and 7 radical 3.
Okay. Artem, for 10, 20, and 50, what did you guys end up with?
For the others,
For both, yeah.
10, 20, and 10 radical 3.
Okay.
For 20, 40, and 20 radical 3. And 50, 100, and 50 radical 3.
Okay, good. Now the big question is, how did we generalize this? How did we generalize this? Jackson, what did you and Jessica, you guys have an unfair advantage with only two of you back there, but what did you guys end up generalizing the short leg with length A as for the other two?
With short leg and long leg?
If your short leg has a length of A, what would the length of the hypotenuse and the long leg be? So that last column in your chart.
Oh, 2A.
Okay, so we're seeing that from the short leg to the hypotenuse, we're doubling. And then from the short leg to the long leg.
A radical 3.
Yeah, it would be A, radical 3. All right. Nice job. You guys are having some good conversations while I was walking around. Okay, so the first discussion question. With your table, describe any relationships you see between the short leg and the length of the hypotenuse. The short leg and the length of the hypotenuse. Colton, what did you guys say over there?
Double to get the hypotenuse.
Okay, so we double, I assume you mean the short leg?
Yeah.
Okay, double the short leg to get to the hypotenuse. Okay, I'd agree with that. Kaylin, what did your group say for the next part? Relationships between the short leg and the long leg.
The short leg numbers in front of the radical.
Okay, so short leg is in front of, what kind of radical?
Radical 3.
In front of radical 3. Okay, good. Let's complete this conjecture then based on the patterns that you guys saw in your chart. In a 30, 60, 90 triangle, if the shorter leg has length A, Taylor, then the longer leg has length,
If A, radical 3,
okay, and the hypotenuse has length
2A.
2A. Very good. And finally, without showing any work or using your calculator, find the length of the hypotenuse and the length of the longer leg if your short leg has a length of 100 inches. So I saw a lot of you drawing pictures, which is great. Emma, what was your length for the hypotenuse?
200.
200, and for your longer leg?
100 radical 3.
100 radical 3. Awesome. All right. Nice job, you guys. Let's kind of sum this up, and let's look at some examples then. Relationships. So again, in a 30, 60, 90 triangle, the hypotenuse is twice or double as long as the short leg. And the longer leg is radical 3 times as long as the short leg. And you can see this in the picture here. Your short leg is A. This is exactly what you guys did on your group work. Hypotenuse is double. The long leg is times radical 3. Okay? Just like we wrote out our relationships last time, we will do a similar type of thing, especially since we have two different relationships here today. I like to say that the hypotenuse is 2 times the short, and the long is radical 3 times the short. So this will help us guide exactly what to fill in, exactly how to solve for whatever we're looking for. Mark had a good question to his group that I overheard in the back. He goes, well, how would we find the short leg if, we're given something else? So, Mark, we will answer your question here shortly. All right, let's look at the first example. Our goal is to find the value of both of these variables. What's going to be really important is that you guys keep in mind what we talked about at the beginning of this lesson in terms of where your different angles are and how that relates to the lengths of the legs. It's going to be easy for you guys to assume that you're always given the short leg maybe, but that's not always the case, so make sure you really pay attention to that. So if our 60-degree angle is here, that must mean our 30-degree angle is the other one. So the length that we're given is the length of the short leg. Why don't we start by finding the length of the hypotenuse? So the hypotenuse is 2 times the short. And we will fill in, just like we did last time, we will fill in the information that we're given. They have the hypotenuse marked with the variable y, so substitute that. Bring down your 2 times, and then Justin, what's the length of our short leg? 8. So then we know that the length of our hypotenuse is 16. We also need to find the length of the long leg, so let's use our other relationship. The long is equal to radical 3 times the short. The long leg is the one marked as x, that is opposite your 60-degree angle. Bring down your radical 3, and like Justin said again, our short leg is the 8. So the long leg is 8 radical 3. I'm going to give your table 2 minutes to look at number 2. 2 minutes with your group to look at number 2. Let's come back together. Let's come back together. Nate, what did your group have for the length of the hypotenuse, which was x? 1. Okay, so we're taking the hypotenuse is 2 times the short. If the short is 1/2, hypotenuse would be 1. And Nate, what did you have for the length of the longer leg? I'm sorry. Okay, so 1/2 radical 3. We can also write this, which I noticed some of you did, as radical 3 over 2. Either one would be fine, okay, just depending on what you prefer. All right, so going back to Mark's question, which was how do we find this short leg given different information? Similar to how we found the legs of our 45, 45, 90 last time. Start with your relationships, plug in what we know, okay? So let's start with the first one. The hypotenuse is 2 times the short. Marlena, what do we know about the hypotenuse?
It's 6.
Okay, so plug in 6 for the hypotenuse. That equals 2 times, Maddie Rolling, what is our short leg?
X.
Our short leg is x. Thank you. So to solve for x, we would divide both sides by 2 and get that our short leg is 3. Okay, you sure?
Yeah.
Okay. Now that we have the short leg, then we can base the long leg off of that. Okay, so the long leg is radical 3 times the short. Once now we know the short, we can substitute that in to get 3 radical 3. 2 minutes with your table for number 4. Except I need to fix something because it's the same problem, yep. We're gonna change that 6 to, I don't know, what do you wanna change it to?
9.
Something.
Yeah, 8 sounds good.
Something that is not odd, but that makes it too easy.
321.
Huh? All right, 5.
Such a boring number.
All right, so 2 minutes with your table. Length of the hypotenuse is 5. Find the lengths of the other sides.
Wait, we can't.
Nope, you're gonna leave those fractions. I think you did that on yesterday's. You can't have guesses.
2, 1 over 2. So like 2 and a half. Or you could put,
You have to leave it as a fraction.
yeah, so 4 and 5. So just
So 2.5 and then 2.5.
So 5 over 3. 5 over 2 over
5 over 13 is.
I'm sore from Monday.
Me too.
I hadn't. We were working on our fitness. Yeah.
I'm in weight.
Come back together. Okay, so why don't we start by backtracking to get the length of our shorter side. Carrie, what did your group have for the length of the shorter side? Okay. And what did your group have for the length of the longer side?
5, 3.
Right, okay. So guys, hopefully you're seeing at this point, the short leg is what the other two are based off of. So that's what we really want to know first. Hypotenuse is based off of that. The long leg is based off of that. Okay? Good. The next example puts a 45, 45, 90 triangle with a 30, 60, 90. So we have to think back to Monday. All right? So, looking at this example, from what we're given, what do we know? From what we're given, what do we know? Nolan?
The short length that has 60 degree is the hypotenuse of the one that has 45 degree.
Okay. Good. So the short leg of the 30, 60, 90 is the hypotenuse of the 45, 45, 90. Good. Okay. What else do we know? Rachel, you had your hand up.
The 45, 45, 90, the other leg is 9.
Okay, so we know the legs are congruent. That's 9. From that, what do we know? Brittany? Okay, so thinking back to last time, the hypotenuse is 9 radical 2. Then we're using what Nolan mentioned, that the hypotenuse is then short leg of the other triangle. So knowing the short leg and needing to know the hypotenuse, let's use that relationship. The hypotenuse is what we're looking for, x. And then we're going to take 2 times that short leg, which is the 9 radical 2. You guys were to do your e-learning assignment for today. It was reviewing radicals. Most of you, I think, have done that. So hopefully we're okay dealing with our radicals. So 2 times 9 radical 2 is what, Justin? 18 radical 2. Good. Okay. 2 minutes with your table for number 6. 2 minutes with your table for number 6. This one was tough. This one was tough. So, Guadalupe, I haven't talked to you yet today, honey. What did your group do first in this one? Okay, I want to know what you did.
We were probably off.
Well, I want to know what she did, not you. No offense.
I would do
Oh.
the short, on the short side, so I did 2 times 13. Not the short side, the hypotenuse.
Okay, but the hypotenuse is double the short side. So we have to find that one first. Okay? Taylor?
So did you do 13 radical 3 divided by 2?
Okay, you guys are trying to do this without writing out your relationships. All right, Carrie, now I want to know.
For the short leg, I thought it was 13 over 2 radical 3.
No.
That's
All right, write out your relationships. You have the long leg, you need to find the short leg. So long is equal to radical 3 times the short. Plug in what you know. The long leg is 13. You can make that short side a variable if you want, so y or z or I don't care what it is. You would divide both sides by radical 3, but then rationalize the denominator. So this is 13 radical 3 over 3 is that short side. And once you know that, then you can double that to get the leg of the other triangle. So what is 13 radical 3 over 3 doubled?
26 radical 3 over 6.
Yep. That is 26 radical 3. Did you say over 6 or 3?
Over 6.
Should be over 3.
Oh, it should.
Yeah.
Why does it say 3?
Because you're only this is like 2 over 1. This is like 2 over 1.
Oh, okay.
You're just multiplying straight across. Okay? Once you know that that leg is 26 radical 3 over 3, how do you get from the leg to the other hypotenuse? How do you get from the, I'm sorry, Steve? Then we need to multiply this by radical 2. So at that point we have 26 radical 6 over 3. That's a good one.
26 radical. Wait.
All right, an equilateral triangle has a side length of 10 inches. Equilateral means that all 3 sides are congruent. So sketch that out. If all 3 sides are congruent, they're all 10. It says to find the length of the triangle's altitude. That is from the vertex angle straight down perpendicular. Well, here's the deal. Once you draw in that altitude, what kind of triangle do we have here? A 30, 60, 90. How do we know that? That's a good question. Equilateral triangle, all 3 angles are 60 degrees. When you bring that down vertical, it cuts it in half, so that's the 30 degrees. Okay, so that's our 60. The other one is the 30. Find the length of that altitude. So essentially, we're looking for the length of the long leg. But what's the length of the short leg? 5. Very good. It's half of the whole thing, which is 10. So if the length of the short leg is 5, what's the long leg? 5 radical 3. 5 radical 3. Yep.